Alright everybody, this is a video on how to create a data frame in Numpy. A data frame, in my opinion, is probably one of the best things that you can possibly work with in regards to any sort of data set. I'm sure there are many reasons to go different routes, whether it be like SQL or whether it be dictionaries or whatever. I love working with data frames. So setting them up is relatively easy, and you have a few different options on how to do that. So we'll go from the start, just as with the rest of the videos, but basically we're going to import NumPy because we're actually going to use a NumPy array to create a data frame. It's not necessarily that you need NumPy when you work with Pandas, but it's very useful to have it. So we're going to import NumPy as NP, which is again by convention. It just allows you to save keystrokes whenever you type it. You don't have to type NumPy every time, you just type NP. We're going to import Pandas as PD. So similarly, same reason, just saves you a few keystrokes and it's by convention. So we'll go ahead and run that. We'll import both libraries. And the first way we're going to create a data frame is using a dictionary. So what we're going to have is a data set. And the data set's going to be a dictionary where the first key is going to be name. And we'll have the keys Bill and Ted. Then we're going to have key name height. And we're going to have the height of Bill and Ted. And we're going to have a weight, a key name weight, and have the weight of Bill and Ted. And I actually took the trouble to actually look these values up for Bill and Ted. So hopefully they're relatively accurate. I don't know the exact height and weight at the time of filming, but these are actually the correct values here. So we'll go ahead and run that. And what that gives you, let's go ahead and make a new little cell here. We'll go ahead and print data out. So we have this little dictionary here. Then I want to actually turn this into a data frame. Well, it's kind of convenient because I've already created these keys here. But what you have is essentially, 3 columns of data and 2 rows, right? You have 2 people, they're Bill and Ted, each person gets a row. And you have the values of their name, which is the first column, the values of the height, which is the second column, and the values of the weight, which is the third column. If I turn that into a data frame, in order to do that, I just do pd.dataframe, and note data and frame are both capitalized. And I just import the data. There's a lot of other optional inputs with data frame, but if you just put in one singular value, that input will become the data. So when we do that, we can print out what's called dataframe.head. What that'll give you is the first 5 values, I believe, by default. In this case, we just have 2 values, but it gives you an idea of what the format is of the data frame, how to view it. There's also a thing called .tail. And remember to always put these empty brackets here. But what that gives you is the tail end of the data set. Doesn't give you the size, doesn't give you anything like that, but it gives you just an understanding of what it is. So here we have our index 0, which in Python is the first index. The name is Bill. The height is 6.08 feet. The weight is 185. And then on index 1, which is the second row, you have Ted, height of 5.78. and a weight of 165. So that's one way you can create a data frame. You can use a dictionary. You can also just do a list or multiple lists, depending on how you want it. Multiple dimensional lists, whatever it is. In this case, we're just doing a single dimensional list here, and it's 1 through 6. So again, I'm calling it data, and here I'm going to call pandas, or PD in this case, .dataframe. And in this case, I actually want to add column names because this doesn't have column names. Previously, we kind of had it. In the dictionary, you already have a key. Well, the keys are automatically parsed and set up as your column names when you use a dictionary. For a list, you don't have that. So what I did is pull in the data, and you can call it data equals data if you prefer. It may even be D equals data, but if you just put in the data, it usually can figure it out. But it also has a parameter called columns. Columns are just the column names. In this top example, it's name, height, weight. Well, here I have numbers 1 through 6, so I just have a single column called numbers. So I'll go ahead and run that. And here you have indexes 0 through 4, which again is 1 through 5 if you want to think of it in those terms. And you have numbers 1 through 5. Again, this is head, so I'm only seeing the top 5. If I put tail, you'll see the bottom 5, right? And you can actually alter that and print out a certain value. I think you can just do 3, and you'll see the top 3. You can do all 6, and we'll see the top 6. So if you wanted to alter those. Let's go ahead and run just that, though. So the reason I imported Numpy, though, was so we could also create a data frame using a Numpy array, which is very, very, very common. So in this case, I have a Numpy array, which is range 0 to 6, okay? And that's, again, saved as data. And here I'm also going to have data, and I'm going to create that columns value there. So I'll go ahead and run that. I call the .head, and you'll see I get those top values. And again, I think depending on, there we go, we have 0 through 5 in that case. So that gives you a decent understanding of what's going on with how to load in through a dictionary, how to load in through a list, or how to load in through an array. This is if you're kind of creating your data, you don't have your data stored somewhere else, right? One more way you can do it in this case is a multi-dimensional array. I mentioned that with list as well, but in this case we're going to do it with an array. Here you have a, a 3 by 3 array. 1, 2, 3 is the first row, 4, 5, 6 is the second row, and 7, 8, 9 is the third row. Then I create a variable called columns, name, age, and weight, right? And now I'm going to create a data frame using the data and the columns equal to the columns. This is very common where you're going to have a variable saved as the column names. It allows you to save it or kind of update it externally outside the data frame and kind of keep it a little bit cleaner, if you will. So when we run that, we have our first column called name, then age, then weight, and you'll see it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So we're actually importing it in the exact format that it's in there. The most useful way that data frames, in my opinion, can be used is when you have an external data set that you want to load in. And in many cases, that data set is a CSV file or an Excel file or something along those lines. So here, Pandas has this wonderful function called read CSV. So all you have to do is call pandas, or in this case pd.read_CSV. You give the name of the data set, and it's really the file path of the data set. In our case, if I come back here to my pandas library, I have a dataset.csv, right? And what I did designate is that my header is equal to the 0th index. This is what that means here. So this is my CSV file. I made it in Linux's version of Excel, LibreOffice or LibreCalc, I believe it is. It's just Excel though. And you have name, height, weight, and career here. This is the parameters, I guess you'd call them. These are the column names. These are what each value in these columns represent. The first column represents the name, the second second column represents the height, etc. If I don't set header equal to 0 or header equal to some value, then it many times will actually associate this to the first row. So no longer do you actually have column names, but you have a first entity, a first row, that instead of having an actual name or an actual height or an actual weight, you just have the word name, height, weight, and career. So if you do have headers, it's very useful to actually designate the fact that you have a header, and this is the index of that header. Okay, so I'm going to load in that data set, and now print the header. What that shows you is you have your indexes here on the left. You have the names of each of these people. You have the height of each of these people. You have the weight of each of these people and the career of each of these people. This is incredibly useful. I'm going to show another video on actually how to index these things. But what I like about this is in a lot of cases when you're referencing data, especially if it's big data, you can't view it in the same way you typically view data. You're not going to go to the Excel sheet and look in this wonderful tabular format and be able to kind of cross-reference these things as intuitively as you can with, let's say, an Excel spreadsheet. The data frame allows you to mimic that, and it allows you to do a lot more than that too. So when you dig in a little deeper, it's really friendly to reference things. But this is how you set it up. There's a few other ways you can set it up. I used these several options because these are the options that I've used often. So there may be other ways that you set it up, either maybe loading in a sample data set through Seaborn or something like that. But in this case, this gives you a good understanding of how can I start? How can I get this off and running? So I hope that was helpful.